Okay, welcome back once again to all my dear students. In the last video, we have discussed about the types of equilibrium, right? That is the homogeneous as well as the heterogeneous equilibrium. Now, in this video, we are going to discuss about the characteristics of equilibrium, then examples, right? So let us start first of all the characteristics of equilibrium. See, whenever any chemical equilibrium is there, the properties just like the color, then concentration, then pressure, then temperature of the system is remain constant, right? Why? Because they are similar in the total area of the system. उसका जो एरिया है ना वो सिमिलर है, that will be we can say is a constant. तो इसीलिए हम पहले तो ऐसा बोल सकते हैं कि कोई भी केमिकल इक्विलिब्रियम है तो उसमें उसका कलर, concentration, then pressure, then temperature of the system is remain constant, right? तो कलर भी कलर, concentration, pressure and temperature. Second point we can say that when the chemical equilibrium is attained, the rate of forward as well as the reverse reaction becomes equal, right? हमने पढ़ा है कि जब chemical equilibrium will be attained, कोई भी केमिकल रिएक्शन इक्विलिब्रियम तक पहुंचती है तो उसका रेट ऑफ फॉरवर्ड दैट इज द Vf एंड रेट ऑफ रिवर्स दैट इज द Vr इज रिमेन कांस्टेंट. दैट इज द सेकंड पॉइंट. थर्ड पॉइंट दैट इज इफ द फैक्टर जस्ट लाइक concentration, pressure, temperature which affect the chemical equilibrium are changed, they produce the effect of equilibrium, right? So we can say that it will affect बाद में हम ऐसा भी पढ़ेंगे कि फैक्टर अफेक्टिंग द केमिकल इक्विलिब्रियम, राइट? सो व्हेनेवर द प्रेशर, देन टेम्परेचर, देन लेट अस सपोज इफ द concentration will be changed, then it can affect the equilibrium. If the initial concentration are different, then the equilibrium constant remain constant at a constant temperature, right? If the temperature is constant, then the equilibrium is also constant, right? Then the value of equilibrium constant changes if the temperature is changes. So we can say that the equilibrium constant is depends upon the temperature. If you change the temperature, then we can say that the equilibrium constant is also changed, right? For the attainment of equilibrium, the reaction can be carried out from left to right and from right to left. Then you all know that when the equilibrium will be reached, then it will be the reaction can be carried out from left to right or from right to left. Left to right किसको बोलते हैं? Left to right, that means we can say that it is from reactant to product, and from right to left, that we can say it is a product to reactant. And last point we can say that there is no effect of catalyst on equilibrium constant. Remember, there is no effect of catalyst on equilibrium constant. Catalyst means what? Then it simply increase the rate of reaction, right? अब for example, अगर मैं यहाँ पे लिखता हूँ कि यूनिट ऑफ इक्विलिब्रियम, चलो यूनिट ऑफ इक्विलिब्रियम हमने पढ़ा है, एक बार फिर से पढ़ लेते हैं इक्विलिब्रियम. चलो, if you want to find out the unit, then the unit of equilibrium that will be in the form of mole per liter. एक रिएक्शन है H2 गैस plus I2 gas, it will give what? Twice HI. अगर मुझे इसका यूनिट फाइंड आउट करना है तो इसका यूनिट क्या होगा? तो Kc, that you all know that concentration of HI whole square upon concentration of H2 and I2. ये concentration का यूनिट क्या है? तो मोल पर लीटर. So I can write out here mole per liter whole square upon mole per liter multiplied by mole per liter. So there is no unit. अगर मैं ऐसा लिखता हूँ कि N2 gas plus 3H2 gas, it will give twice NH3 gas. अभी देखो इसका यूनिट क्या आएगा? तो you all know that it is equals to concentration of ammonia square upon concentration of N2 and concentration of H2 whole cube. So what is the unit? I can say mole per liter raised to minus 2. Understand? Is it clear? So this is how you can find out the unit for the any equilibrium constant. कोई भी chemical reaction दिया हुआ है और उसका यूनिट मुझे फाइंड आउट करना है इक्विलिब्रियम कांस्टेंट का, so this is how you can find out the unit. Okay, चलो नोट डाउन कर लो. चलो एग्जांपल देखते हैं. The equilibrium constant of the reaction, the equilibrium constant of the reaction H2CO plus H2O plus H2O gas, it will gives what? CO2 plus H2, CO2 gas plus H2 gas, right? Okay, now Kc is given 4.25. Kc is 4.25 at how much temperature? 810 Kelvin temperature. At 810 Kelvin temperature, right? Now suppose if the reaction begin with the reactant having concentration, suppose the initial concentration of reactant is 0.1 mole per liter, right? So calculate the concentration of, then calculate the concentration of what? CO2, then CO, then H2O, right? And H2 at equilibrium constant, and H2 at equilibrium constant. Equilibrium constant. चलो मुझे पहले तो रिएक्शन यहाँ पे दी हुई है, ये देखो ये रिएक्शन और उसका इक्विलिब्रियम कांस्टेंट. At equilibrium you have to find out the concentration of CO, H2O, CO2 and H2. Let us see. पहले तो मैं रिएक्शन लिखता हूँ. चलो सॉल्यूशन यहाँ पे रिएक्शन, कौन सी रिएक्शन? CO गैस plus H2O gas, it will give what? CO2 gas plus H2 gas. Understand? This is the one reaction will be given. Okay. तो इनिशियल कॉन्सेंट्रेशन क्या है? यहाँ पे मैं लिख रहा हूँ इनिशियल कॉन्सेंट्रेशन. चलो इसका कॉन्सेंट्रेशन कितना दिया हुआ है? तो इनिशियली इट विल बी गिवन हाउ मच? 0.1. सी अगर अगर ये 0.1 मोलर, here also 0.1, at that time there is no product will be obtained, उसकी प्रोडक्ट नहीं मिलेगी. अब देखो कॉन्सेंट्रेशन है इक्विलिब्रियम कॉन्सेंट्रेशन. चलो तो इक्विलिब्रियम में कॉन्सेंट्रेशन कौन सा है? तो 0.1 माइनस x, क्योंकि ये x है ये भी x है, तो जितना कॉन्सेंट्रेशन प्रोडक्ट का बढ़ेगा उतना ही कॉन्सेंट्रेशन रिएक्टेंट का क्या होगा? डिक्रीज होगा. हमने पढ़ा कि as the concentration of the product will be increased, then the concentration of the reactant will be decreased. तो ये भी 0.1 minus x. Understand? Is it clear? Now you all know that you have to find out what Kc. So Kc हम लिखते हैं Kc equals to concentration of CO2, concentration of H2 divided by concentration of CO and concentration of H2. Understand? Put the value over here, right? So here x multiplied by x upon 0.1 minus x and 0.1 minus x. Is it clear? That is Kc. Now यहाँ पे देखो Kc दिया हुआ है 4.25. So right here 4.25. So right down here 4.25. That is equals to x square upon 0.1 minus x whole square. Right? Now put the value. We bring it here. What? That x square equals to 4.25 into 0.1 whole square minus 2 0.1 into x minus plus x square. Understand? A minus b whole square. Now here you will get x square equals to क्या होगा, तो ये यहाँ पे मल्टीप्लाई होगा 4.25, ये 0.01, right or not, and this will be multiplied, so minus 0.2x plus x square. चलो x square equals to इसके साथ मल्टीप्लाई करो तो 0.0425 माइनस, तो इसके साथ तो 4.25 मल्टीप्लाई बाय 0.2 0.850x plus 4.25x square. Is it clear? Right? Now put here the equation, it becomes this minus x square, so 3.25x square minus 0.850x and plus 0.0425, and that is equals to 0. Understand? Now you want that ax square plus bx plus c equals to 0. Now this is how you can calculate what alpha and beta. Understand? So what is a? 3.25, b minus 0.850 and c 0.0425. Now put the value, you can get the answer. Understand? So what is x? X that is equals to, you all know x equals to minus b plus or minus root b square minus 4ac upon 2a. Put the value, you can get the answer. Okay? Chalo note down the ओके। चलो अब हम देखते हैं एप्लीकेशन ऑफ इक्विलिब्रियम कांस्टेंट। चलो एप्लीकेशंस ऑफ इक्विलिब्रियम कांस्टेंट। नेक्स्ट पॉइंट, एप्लीकेशन ऑफ व्हाट इक्विलिब्रियम कांस्टेंट। इक्विलिब्रियम व्हाट कांस्टेंट। Okay, चलो some of the important applications of equilibrium constants are there. So first one, that we can say prediction of completion of reaction. First one, that we can say prediction of completion of reaction, right? When the reaction will be completed. So the value of equilibrium constant shows the proportion of completion of reaction. If the value of Kc is greater than 1, then more proportion of the product can be obtained, right? So I can write down here now what is Kc and what is Qc, that you have to know. So I can write down here, if the value of Kc is greater than 1, if the value of Kc greater than 1, अगर Kc की वैल्यू 1 से ज्यादा है तो प्रोडक्ट विल बी ऑब्टेन, मोर प्रोडक्ट विल बी ऑब्टेन, मोर प्रोडक्ट विल बी ऑब्टेन, राइट? मोर प्रोडक्ट विल बी ऑब्टेन. These things you have to know, that is the reaction getting product from the reactant will be towards completion. That is, I can say the reaction, whatever the reaction is there, that is we can say the reaction of getting product from the reactant, of getting product from the reactant, right, will be towards completion, will be towards completion. Like if, now second point, if the Kc is less than 1. Second, if the value of Kc less than 1 then the proportion of reactant will be more than the proportion of reactant will be more as compared to what? As compared to product. And so there will be decrease in the tendency of completion. So there will be decrease in tendency of completion of the reaction. Completion of the reaction, right? And if Kc is equals to 1, then the reactant and product will be in equilibrium state. If Kc equals to 1, then the reactant and product will be at equilibrium state. Will be in equilibrium state. यहाँ पे देख कि Kc की वैल्यू पे डिपेंड करता है कि अगर Kc greater than 1 है तो Kc less than 1 और Kc equals to 1. Now second, that is application, that is a prediction about the forward and reverse direction of reaction. So second prediction of forward and reverse direction reaction. Of forward and reverse direction reaction. Right? चलो पहले तो किस डायरेक्शन में रिएक्शन होती है. So the prediction about the reaction at any stage will occur in the direction of whatever the value of Kc, that is the equilibrium constant, that is depend upon the equilibrium constant. Now let us suppose if I write here the reaction. यहाँ पे देखो AA plus BB gives CC plus DB, एक reaction. Now if I want to find out, if I want to write down the Kc, then how I can write down the Kc? That you all that Kc equals to concentration Cc dB upon AA and BB. Understand? And that is equals to what? QC. QC, that is a quotient. Is it clear? If now if I write if Kc is less than QC or QC greater than Kc, right? QC, that is a quotient. Okay, then the reaction occur in forward direction. Then the reaction occur in forward direction. That means we can say that from reactant to product, right? From reactant to product. Can I jump? Reactant to product. Is it clear? Right? Next, if this is the first point, if Kc greater than Qc or Qc less than Kc, then the reaction will occur in reverse direction. Then the reaction occurs in reverse direction. That is from product to reactant. From product to reactant. Understand? Is it clear? And the last one, that if Kc equals to Qc, then we can say the reaction will remain in equilibrium. The reaction will remain in equilibrium. Equilibrium. Understand? So these things you have to know. So these are the two different applications for the equilibrium constant. first of all note down, and then after we are going to discuss some example related to this application. चलो note down करो. चलो अब हम एग्जांपल देखते हैं. The value of Kc for reaction, the value of Kc for reaction H2 gas plus I2 gas gives twice HI gas is 57, right? And at 700 Kelvin temperature, at 700 Kelvin temperature. चलो अभी देखो, suppose the concentration of the product in the reactant यहाँ पे दिया हुआ है. अगर यहाँ पे H2 का concentration है कितना, 0.01 molar, then concentration of I2 will be given, it will be given 0.1 molar, 1 molar, and concentration of HI will be given how much, 0.20 molar, 20 molar. Okay, चलो अब देखो मुझे फाइनल करना है. डिटरमाइन इन विच डायरेक्शन द रिएक्शन विल occur. डिटरमाइन इन विच डायरेक्शन द रिएक्शन विल occur. मुझे डिटरमाइन करना है कि कौन सी डायरेक्शन में रिएक्शन occur होगी. तो चलो देखते हैं. तो फर्स्ट ऑफ ऑल आई कैन राइट द रिएक्शन दैट H2 gas plus I2 gas, it will give what, twice HI gas. Clear? चलो तो मैं यहाँ पे ऐसा लिख सकता हूँ कि Kc equals to what, concentration of HI whole square upon concentration of H2 and concentration of I2, and that is equals to Qc. हमने पढ़ा है. अभी देखो कि Qc equals to, मैं ऐसा लिख सकता हूँ Qc equals to क्या, तो HI क्या है, तो 0.20 का स्क्वायर डिवाइडेड बाय 0.05 एंड 0.1. सो यहाँ पे आंसर कैलकुलेट करो 0.04 डिवाइड बाय 0.005. तो यहाँ पे कैलकुलेट करना पड़ेगा, तो आंसर आएगा 8. तो यहाँ पे ये 57 दिया हुआ है Kc. So I can say that Kc is greater than Qc, right? Or you can say Qc is less than Kc, or Qc is less than Kc. That's why we can say the reaction will occur in the forward direction. Reaction occur in, अभी भी हमने देखा forward direction. Forward direction means from reactant to product, right? Reactant to product. चलो नोट डाउन कर लो. चलो नेक्स्ट एग्जांपल देखते हैं. To find out the equilibrium constant, right? Next example है 6.9 gram N2O4 is taken. 6.9 gram N2O4 is taken in a closed vessel of 0.5 liter volume. In a closed vessel of 0.5 liter volume. Understand? Temperature is given. Temperature is 400 Kelvin दिया हुआ है. एंड इक्विलिब्रियम रिएक्शन यहाँ पे दिया हुआ है कि N2O4, राइट? यस, इट विल गिव्स, क्या है? इट विल गिव्स NO2 गैस प्लस यहाँ पे दिया हुआ है प्लस ट्वाइस NO2 गैस. ओके, एंड इक्विलिब्रियम कांस्टेंट and equilibrium or total pressure is at equilibrium constant, the total pressure is somewhat 9.15 bar. 9.15 bar. Understand? You have to calculate Kc, Kp and partial pressure. Calculate Kc, Kp and partial pressure of equilibrium. Understand? Is it clear? तो यहाँ पे R की वैल्यू क्या ले लिया? 0.082, and you all know that unit liter, then atmosphere, mole inverse, Kelvin inverse. Liter, atmosphere, mole inverse and Kelvin inverse. Understand? चलो, तो हम कैलकुलेट करते हैं. पहले तो मैं रिएक्शन लिखूंगा यहाँ पे. कौन सी रिएक्शन है? चलो पहले तो N2O4 gives twice NO. It will be in the form of gas. देखिए, तो पहले तो मैंने ऐसा बोला था कि कोई भी का मास अगर ग्राम में दिया हुआ है तो पहले मोल में कन्वर्ट कर दो. तो मोल्स ऑफ N2O4 ऐसे राइट. सो मोल्स ऑफ N2O4 इक्वल्स टू मास कितना है? 6.9 ग्राम एंड मॉलिक्यूलर मास फाइंड आउट करो. N2O4 का कितना? 92 आएगा ग्राम पर मोल. फाइंड आउट कर दो. कैन सी से 0.075 क्या है? Understand? Now you all know according to ideal gas equation. Ideal gas equation, you all know that PV equals to what? nRT. Right? Paragraph here P equals to nRT by V. Understand? So put the value, you can get the pressure. चलो वैल्यू यहाँ पे रख दो. तो ये क्या आएगा? यहाँ पे n क्या है? तो मोल्स कितना है? 0.075 into 082 into टेम्परेचर कितना है? 400 डिवाइड बाय वॉल्यूम कितना है? 0.5. चलो प्रेशर आ गया. तो प्रेशर हमको मिलेगा, देखते 4.92. Understand or not? Right? So this is how you can get the pressure. Now you have to calculate what? That equilibrium constant. कैसे कैलकुलेट करते हैं? तो चलो देखते हैं. यहाँ पे देखो, इक्विलिब्रियम कांस्टेंट मुझे कैलकुलेट करना है. तो ये एक रिएक्शन है N2O4. इट विल गिव्स व्हाट? ट्वाइस NO2. दोनों गैस में. तो इनिशियल कॉन्सेंट्रेशन यहाँ पे इनिशियल आएगा कितना था? तो 4.92 यहाँ पे आया. तो इट विल बी एट दैट टाइम इट विल बी 0. अब इक्विलिब्रियम पे क्या होगा? यहाँ पे इक्विलिब्रियम है, राइट? तो इक्विलिब्रियम पे क्या होगा? ये सपोज इफ आई x, तो यहाँ से 4.92 माइनस x आएगा. अंडरस्टैंड? नाउ व्हाट इज टोटल प्रेशर? नाउ टोटल पार्शियल प्रेशर दैट इज इक्वल्स टू टोटल पार्शियल प्रेशर इक्वल्स टू क्या आएगा? पार्शियल प्रेशर ऑफ व्हाट? N2O4 प्लस पार्शियल प्रेशर ऑफ NO2. 2. अंडरस्टैंड और नॉट? सो यहाँ पे टोटल प्रेशर तो मुझे दिया हुआ है कितना है, तो यहाँ पे ये देखो 9.15 है, सेकंड आएगा ये 9.15 इक्वल्स टू 4.92 माइनस x प्लस 2x. अंडरस्टैंड? सो पुट द वैल्यू. सो x इक्वल्स टू क्या आएगा 9.50 माइनस 4.92, क्योंकि 2x से x गया तो 1x रहा, तो दिस इज इक्वल्स टू व्हाट, लेट मी कैलकुलेट. Okay, 4.23 bar. 4.23 bar. This is the value of x. Now you can get the concentration of what? PN2O4 and PNO2. Now it will be easy for you, right? How to find out the concentration? See, यहाँ पे P क्या होगा? N2O4 that is equals to 4.92 minus x की value 4.23. So that is equals to how much? So 0.69 bar, 69 bar, or P NO2 that is equals to 2 into 4.23, so that is equals to 3 to the 6, 4, 8.46 bar. Understand? Right? Now you have to find out what Kp. Now you all know that what is Kp? Kp equals to P NO2 whole square upon P N2O4. Put the value, you can get the answer, right? Now यहाँ पे क्या आएगा? तो 8.46 divided by whole square divided by 0.69. चलो फाइंड आउट करो, ये वैल्यू आ जाएगी 103.73 bar. This is what Kp. And now with the help of this, you can find out the Kc. How? That Kp equals to Kc into RT raised to delta Ng. Now what is delta Ng? That you all know. Subject Kc. So Kp upon RT raised to delta Ng. Put the value, you can get the answer. चलो note down कर लो. Okay, now next one, that is the relationship between equilibrium constant as well as the Gibbs free energy. Let us see relation between the equilibrium constant and Gibbs free energy. Relation between equilibrium constant and Gibbs free energy. Gibbs free energy. चलो इसके बीच में रिलेशन हम एक्सप्लेन करते हैं. केमिकल इक्विलिब्रियम हैज अ नो रिलेशन विद द केमिकल काइनेटिक्स. कि कोई भी केमिकल रिएक्शन होता है तो वो कितने टाइम में वो रिएक्शन कंप्लीट होगा उसके साथ कोई रिलेशन नहीं, बट इट इज डेफिनेटली रिलेटेड टू द थर्मोडायनामिक्स. वो थर्मोडायनामिक्स क्या हमको समझाता है कि कोई केमिकल रिएक्शन होता है तो वो अपने आप होगा स्पॉन्टेनियसली और नॉट, राइट? एंड होगा कि नहीं होगा वो भी थर्मोडायनामिक्स में हम एक्सप्लेन कर सकते हैं. तो इन थर्मोडायनामिक्स द चेंज इन द फ्री एनर्जी डेल्टा जी दैट इज नोन एज द गिब्स फ्री एनर्जी, राइट? एंड द डिफरेंस नाउ यहाँ पे हमको फाइंड आउट करना है कि डिफरेंस इज दिस डिफरेंस इज द डिफरेंस बिटवीन द व्हाट टोटल फ्री एनर्जी एंड द प्रोडक्ट एंड टोटल फ्री एनर्जी ऑफ द रिएक्टेंट. अभी देखो पहले तो हम ऐसा लिख सकते हैं कि इफ द वैल्यू ऑफ डेल्टा जी इज नेगेटिव देन द रिएक्शन विल बी स्पॉन्टेनियस. इफ द वैल्यू ऑफ डेल्टा जी इज नेगेटिव देन द रिएक्शन इज व्हाट स्पॉन्टेनियस. कि अगर डेल्टा जी की वैल्यू नेगेटिव आई तो रिएक्शन अपने आप होगा. इफ दैट मीन्स द फॉरवर्ड रिएक्शन, राइट? इट ऑलवेज प्रोसीड द डायरेक्शन टुवर्ड्स द प्रोडक्ट, right? That is a forward reaction. यहाँ पे एग्जांपल लेता हूँ, that is forward reaction. Forward reaction. If the value of delta G is positive, then the reaction is non-spontaneous. Reaction अपने आप नहीं होगा. That means we can say that reverse reaction, or you can say the direction from product to reactor, or you can say that is reverse reaction. Reverse reaction. Understand? And if the delta G is 0, then the reaction will be at equilibrium. If delta G equals to 0, then the reaction is at equilibrium. Understand? Right? So these things you have to know. Now according to the thermodynamics, let us see the relation between the, यहाँ पे मैं ऐसा लिख सकता हूँ कि डेल्टा G equals to डेल्टा G0. 0 है तो that is a standard gives free energy, right? E plus RT ln QC. Now you all know that what is QC? That is equals to KC at equilibrium, right? So I can write down that delta G, that is standard free energy, gives free energy, R gets constant, T temperature, and QC, that is a quotient, right? And at equilibrium, I can say delta G equals to 0 and QC equals to KC. Like right now, delta G, that is 0 equals to delta G0 plus RT and then KC. So right now, delta G0 equals to minus RT and then KC. Understand? And from this, I can also write down here that delta G0 equals to minus 2.303 RT log KC. Understand? Now, if I want to write down this equation by taking anti-logarithm, then okay. Now see here that if delta G0 is less than 0, अगर ये delta G0 less than 0 है, means negative. So when you are negative will be positive. So the K will be greater than 1. And delta G0, then we can also say that this term will be positive. So this will be greater than 1. So when the K is greater than 1, then we can say that the reaction will be occur forward and spontaneous. If delta G0 is greater than 0, greater than means 1 है तो ये नेगेटिव आएगा, तो delta G0 by RT will be negative, so KC is less than 1, and so the reaction will be non-spontaneous. And the last one, that if the delta G0 will be 0, then we can say that it will reach at the equilibrium position. Understand? So now let us discuss one example related to this topic, right? So let us see one example. चलो, the value of equilibrium constant reaction, the value of equilibrium constant reaction, right, of phosphorylation of glucose during of glucose during what? During glycolysis was obtained. During glycolysis was obtained. Understand? Then 3.8 into 10 raised to minus 8. 10 raised to minus 8 at how much temperature will be given? 298 Kelvin temperature. Then you have to calculate what? That gives free energy. And you have to write down the opinion of that reaction, whether it will be spontaneous or not. See here. First of all, K will be given. See. 3.8 into 10 raised to minus 8. Right? Temperature is given 298 Kelvin. Now you have to find out what? Calculate delta G, standard free energy, right? So you all know that delta G0 equals to minus 2.303 RT log Kc. तो पहले मुझे ये तो मालूम है माइनस 2.303 इंटू 0.082 इंटू 298 इंटू लॉग क्या आएगा 3.8 इंटू 10⁻⁸। इसका सिंप्लीफिकेशन करना आपको आना चाहिए। तो ये क्या आएगा लॉग 3.8 प्लस लॉग 10⁻⁸। सो लॉग 3.8 माइनस 8 लॉग 10। चलो 3.8 का लॉग क्या आएगा वो देख लो, और जो भी आए वो 8 में से माइनस कर दो। सॉरी 10⁻³ है तो 3 में से माइनस कर दो। चलो ओके, दिस 10⁻3, ओके, नॉट -3। इज इट क्लियर? सो हियर 3 में से माइनस करो तो जो भी आए और उसके साथ मल्टीप्लाई करो तो द रिएक्शन वी कैन से दैट वेदर इफ इट इज नेगेटिव then you can say that the reaction can be occur on its own. Understand? चलो मैं कैलकुलेट करता हूँ। ओके, तो ये नेगेटिव आएगी तो यहाँ पे क्या आएगा, ये -2.3